this presentation, you can see different kind of things. One is about the introduction to geothermal electricity, because I know that probably that would be like a new topic for some of you. I try to be as bad as I can. Then I'm going to talk about the geological background of that, because the geothermal energy comes from the mother group and it's related to the geology. And then I'm going to tell you about the main components of the geothermal power plant, because what's weird about geothermal is just a direct heat or heating and cooling purposes. Today we're going to focus much more on the power plants. Then you're talking about what type of geothermal power plant we have available and why it could be applicable around the United States, whether you're like in a very hot, you're in a cool, and still it could work for. Then talking about the advantages of challenges, what would be the path forward, because I really want to I'm just like, I think now all of you are the volunteer for the CCL, and then you try to request something from the representative or the senator. What should be our question and request from them, because we have all these around it. So as everybody know, the geothermal energy is heat inside of the air. Okay? And that heat comes from different sources. Part of the energy comes from the residual heat left from the earth formation. Part of that comes from the decay of the uranium and other nuclear, and that causes the heat. And the rest of the energy comes from the meteoric impact. So as you see that all of these reasons are natural. So our Earth was a burning planet billion years ago. And the temperature, core temperature was 5,000 degrees Celsius. And this is the main reason that the people believe that inside of the core of the Earth is just even high heat inside of it compared to the solar energy. Right? Geo and therm. Geo means Earth, and the thermal is actually the heat energy that you're working on. So this energy is derived from those parts of the Earth which are much more active, and we call that the tectonic activity. So looking at like the left part and the right side of the United States, like the Pacific Ocean and also the right Atlantic Ocean, we know that we have some active plates. And these are the places that actually you would see like that energy could be higher compared to the other places. Besides that, we know that those are the places that we're going to have like the higher number of the volcanoes and earthquakes, right? Besides to seeing like the geothermal energy. So we all know that the Earth have different parts, the crust, mantle, and core, and these energy that we are trying to work with is coming from different parts of these. You see, this part of like the Earth. And the main reason that I put this slide is that later on, when we are talking about, for example, for different geothermal power plants, what depth we need to work with, then you will understand that how close or how far we are from the core of the Earth. A long time ago, actually, people used this geothermal energy without even noticing that, because looking at the hot springs that people have, they use that for their skincare, they use that as medication, and they really didn't know that where is the source of that energy, but they use that for like the medical purposes. And actually, like the first geothermal power generator used for generating the electricity happened until the long time ago, right? But now, since we are focusing on just the geothermal power plant, I want to give you the idea like how these processes work. Whenever that we have like this kind of a conversation, people usually say that you should share that lot of information with the people and just walk them through like the components of the system. But what I believe is that usually having the knowledge of how the system is working gives you a better understanding of what you really want. You really want to see that? You want to work with this system or not? It doesn't matter like if you don't understand part of this, but I try to make it as simple as possible. At any point, if you feel like part of it doesn't make sense to you, just stop me and ask me the question. Okay? Looking at the geothermal power plant, we are working with production well and injection well, right? And besides to that, it really depends on like how much electricity you want to generate the amount of the numbers or the numbers of the production well and injection well could be increased or decreased. But at least you need to have one production well and one injection. But between these two systems, between these two wells, the majority of you are familiar with the oil and gas wells, right? So between these two wells, we have other systems like the separator, heat exchanger, steam turbine, condenser, and generator to get that electricity. So now I'm going to go through each of them to give you the idea of how it is. Looking at the production well, that would be our source of the SC, okay? The depth would be between 3 kilometers to 10 kilometers, and it would be similar to the production well of oil rig. Well may be located as far as 10 kilometers to 14 kilometers apart from the power plant, okay? And the steam could be moist or dry, and later on we're gonna discuss that because we have different type of power plant, and in each of them I'm going to explain to you that why it's working because they're working in different temperatures. And water or brine could be re-injected through the injection and like improving our system. One thing that I want to mention to you before we go on to the different part of like the geothermal electricity generation, I want to emphasize on the fact that for developing any geothermal energy, we need 3 components, okay? We need to have like the heat, okay? We make sure to have like the temperature enough to get that energy. We need to have like the fractures. Why? Because we need to see like through those fractures that heat come to the earth. And the third component is the fluid or any carrier that can carry that heat to the surface of the earth. Okay. So at any of the points that we are losing one of these 3 parameters, heat, fractures, and of course like those fluid carrier, we can improve the system. And we call that as enhanced geothermal system. Because it's not a conventional system. The conventional system needs to have those 3 components. Okay? When we lose one of them, we can actually add that component to the system. So now I have a very short video, if I can show to you. Here. Do we care about that? Because those are the draining bits. So if those components would help us to work with and make those holes inside of here. Okay? So now we have this separator. When we have that heat, right? Part of the heat we don't need that. So what the separator does is just, as you see, the steam that we have contains non-condensable gases. And one of them is hydrogen sulfide. We don't need that. So what the separator will do is just like it separates the things that we don't want to see in the system from the things that are like necessary in our system. Okay? And as we see, the separators are usually vertically, horizontally designed. So it really depends on what kind of system are we working. Are we working with a closed system? Are we working with the open system? But depending on that, you see that it will be changed. Wait, for the they're gonna collect that and then they're gonna recycle it. Because it's a part of the thing that they wouldn't need it anymore. No, because usually when they're working with hydrogen is like one of those burning kind of and very flammable gases, right? It's very difficult to work. They make sure that they collect it and they make recycle it. And now this is actually in West Coast because they produce so much hydrogen over there. They try to produce it and they get a source of energy for generating electricity. But it's like a byproduct of thing. That was a very good question. So now for the steam turbine, as you see, this is designed For the geothermal power plant, the steam can be corrosive due to many condensable gases, as I mentioned, sulfide is one of them. So to protect the rotor blade and nozzle from the corrosion, special coating and materials are used because same as the well, we know that the corrosion and scaling can happen because now that when you're drilling the hole inside of the earth, you're gonna see also different kind of components inside of it, including the calcite, carbonite, and other components which causing the corrosion. And as you see that this is like again same as the other probably steam turbine that you've seen around. Yes.
What temperature? What you created?
We're gonna discuss that here. We can pick any kind of temperature. So and this is the condenser because later on, depending on what type of actually power plant you're working with, the steam needs to be condensed so that we can use that as like a liquid, right? So it really depends on what kind of, if you look at here on the figure that we have on the right, you see the cooling water in it and the cooling water outlet. So what it does, it tries to condense that steam because what we got will be very hot temperature, and then they condense it and make it like a liquid, like a water that we have. And now at the end, we don't have like an injection. So look at like the system that we have. This is the natural heat source. We have the fracture, as I said, this is one of the other components that we need to see. Then we have our cap rock, same as the oil and gas. Look at on the very right part, you see the power plant, you see the cooling tower. So all these components are related to each other. And as you see, there is a cycle because every time when you're working on one thing, we see that you have your production well, you have your cooling tower, you have your, again, you have your water injected to the earth. And then again, that's because we have the natural heat source, it makes it again hot and then comes back. So you will be in a closed loop system. Okay. Looking at that, just keep that in mind. This is the figure that we're seeing now, right? Because since I'm going to talk about like what will be the advantages, I'm also going to talk about the challenges and some of the issues that we have. Okay. How it works, again, we have the large holes there, pipes are over there inside of those holes. The production was two processes converting the geothermal energy into the mechanical energy. And then we have the mechanical energy into the electrical energy. The success of the energy production depends on the temperature, as Paul mentioned, and actually depends on the temperature of the rock that we have in the earth. We have the water sent into the injection, and later on, I'm going to talk about like when we do not have that water as like the heat carrier. What are the other sources that could be used when we do not have that high temperature? So now, due to the high pressure, when it reaches to the topmost of the earth, it's converted into just the steam, right? Because we do not have that, because the layers are very pressured. Looking at over here, we would see the cap rock, we see the groundwater aquifer, and when it comes back, we see that it would be steam again. And this is the main reason that we are using the condenser one more time. So the high pressure, the pressure that we see inside of here, and the low pressure actually helps that the turbine starts running, okay? And then the generator is coupled with the turbine to produce the electricity. So it's really depending on where you're working with, you're changing the system, right? We are injecting and then again producing. You know, same as the oil and gas field. We're causing like some kind of changes in the pressure inside of the earth, right? If you're very close to, let's say, an active fault or active zones of the earth, that may cause the earthquake because it's still like just trying to causing like change in the pressure inside of the earth. For that specific reason, all the companies who are in charge of doing those testing, they are in charge of like doing also the seismic survey to make sure that they are not changing the pressure inside of the earth. So the seismic survey to monitor the changes that are happening if they are very active. For example, in North Dakota, since we are not very close to any active fault, it's pretty safe. So people are not worried about like doing any kind of a project over there. And this is one of the main reasons that they're also developing as you know, they're also developing the unconventional oil and gas energy over there because they are pretty sure that nothing will happen in the years up here. But in Oklahoma, for example, because they're very close to the active zones, they need to monitor that constantly. And actually, they develop the geothermal project over there because they use both abundant oil and gas over there, and they repurpose that for the geothermal. So now it's very quick to see the whole process verbally explained to you.
Energy is a steady supply of electrical power with minimal environmental impact. Here's the basic process. Water in underground reservoirs is heated to high temperature by magma. Production wells drilled up to 10,000 feet below the Earth's surface tap into this hot fluid. Under its own pressure, the fluid flows through these wells toward the surface. As it travels, the pressure lessens, causing a small amount to become steam. Together, the hot fluid and steam move through a surface pipeline to a wellhead separator, where the pressure is reduced. Here, most of the fluid vaporizes and flashes into high-pressure steam. Any fluid not flashed into steam moves to a standard pressure crystallizer to produce standard pressure steam. Remaining fluid is then flashed at a lower pressure to create low-pressure steam. All steam created in the plant is sent to a turbine on site. The force of the steam spins the turbine's blades, which turns a shaft connected to an electrical generator. An electrical charge is created and directed to a transformer, where the voltage is increased and sent down power lines. It's not flashed into steam, return to the underground reservoir, where in time they will be reheated and reused. Geothermal energy, a simple, clean, and renewable energy source.
So just for them, now, one of the questions that we got was just like what are the temperature that we are working around. We're going to feel like that the geothermal plant actually have different type and different temperature. We have the dry or steam power plant actually working with a very high temperature. It's similar to what we see in California and why? Because they have a natural reservoir over there. They're very close to the volcano and active zone, so they have a very high temperature over there. You see that it's 356 to 437 Fahrenheit, and the pressure is also high over there. They technically do not need to do anything over there because they already have the steam over there, right? So, and they can achieve up to like 1 kilowatt hour per 6.5 kilogram of the steam. Okay. This is a very simple one, which is like the one that actually have everything available. They have the temperature, they have the hot temperature, so they have everything over there. Then, and this is like the way that it works. This is the injection well, as you see that we have the turbine, but since we have like the steam over there, we do not need to do any specific thing. We have like a condenser, just cool the water and then send it back to the and then actually that water will be heated again and come back to production. Now we have the flash steam. So this is actually, as you see, this one is not working similar to the other. And the main reason is that the temperature over here would be lower compared to the previous. What's going to happen is that in this one, you see that the steam with water extracted from the ground. And why do you see the water? Because the temperature is lower compared to the previous. The steam separated from the water from using the separator. The turbine drives the electric generator, and it can also generate between 5 to 100 megawatts. And then when I'm giving you these numbers, these are like the natural things that we're doing, right? So what I'm trying to tell you is that these are like our raw data that we are getting. We are not manipulating the system. This is how naturally it can happen. What they do is just like that they're adding some component to get like electricity out of the system. So this is the convention. This is not enhanced geothermal, the temperature or any of the other components that I mentioned. So looking at that, you see that the flash scene, we have volume on is just like this salted water, called it as brine. So we have a salted water, we have also the steam. So as you see that they need to be separated and then they need to be sent to the turbine. When we have the steam, again come back to the down. We have the condenser because we want to make sure that we put the system back to what it was originally, coming back to the injection mold, and then move to the on and off. So now we have the binary cycle part. This is actually the one that works with the low temperature. Meaning like that, the water itself cannot take enough energy because the temperature is not high over there. So what will happen is that even if you have a 100 to 150, you can use the binary power. What will happen is that we use some heat to vaporize the organic liquid. They use the isooctane or isopentane. And what will happen is that that energy and that component of organic liquid cause the vapor to drive to the turbine. And this is the main reason that now the system could start working. As you see, it can produce between 0.1 to 40 megawatts. And again, this is totally naturally without improving the system. So that happens naturally. But the only thing that they are trying to do is just try to change the system itself. Goes into the loop. It would be still in the system as much as the system. If the power plant is running for 10 years, it would be there for the 10 years, and when they're done, they're gonna receive
to reduce the efficiency of use energy, heat up water to make it steam. That really makes sense.
Yes. And the main reason is just like that when we have like the low temperature over there, right? We have the low temperature, somehow we need to improve it. And for that reason, we have, because again, we want to get the steam, right? And since it's just like it cannot go high, we need to improve the system to actually generate that steam. So for that reason, we need to spend energy, and that causes reduce the efficiency of the system because we're putting extra energy into the system.
You're not burning the butane because that's lower boiling temperature.
That's correct. You're not burning anything.
Those organic compounds.
This percent that you see is counting like that part of the energy and part of the heat material. But those are actually the organic matters that can actually keep the heat so much. So they will not be worried about losing that much heat.
Why don't we look at the system?
It would be the close. Look at when you look at this system, right? So you see that there is no place over this system that would be right? Because it's always in the closed loop system. So it wouldn't be inside of the environment.
Well, because they have a lower boiling temperature than water.
Exactly, yes. No, because of the pressure and the temperature that they're working with. And every year, I guess they develop like or they found the new component that actually could be used with their norm and they want to recycle that, they can also impact. So that they know that what pressure and what temperature it works here, like depending on the engineer knows about like loop formation. So they make sure that they wouldn't like go beyond like that specific temperature and pressure and carbon condition. So they wouldn't go to further lower. I mean, I guess that if last year we're just saying that we can use the supercritical CO2 because CO2 when it comes to the specific there, it changes the phases. So instead of becoming like the gas, it becomes liquid. So they use that as well. But it cannot go to the deeper formation. This is one of the main reasons. So it cannot go very, it can happen very shallow surface. So this is an issue that they cannot use supercritical instead of like those. Yes.
So my area in fact could be something a place like Minnesota.
Yeah. You have a question?
I was just curious about, which, type of power plant is that you recommend? Rather than
Yes, yeah.
where there are no plants.
Yeah. So when you're talking about the electricity generation, so they usually put the power plant outside of the city. They wouldn't usually put that inside of the city to make sure that they wouldn't impact it. Because later on, I'm going to show you the environmental impact, and one of them is like the noise and the pollution that it may cause. So they usually put it outside of that. But any of those systems, since they're closed loop, and when they see something outside of there, they wouldn't differ from which one would be appropriate to put as in the residual area. The only difference that we can see and observe over there is just that there, depending on the geology that we have in an area, what would be the best option that we can. There was a yes.
Yeah.
Yes. Exactly. Yep.
I'll say.
Yeah, so this, if you want to elaborate this one, or let's say connect this project with something that happens in Oklahoma. So this one, since we're still using like the heat over there, the amount of the water that they inject for the oil and gas, which cause like the issues in Oklahoma, is drastically different from the amount of the water that they're putting over here. The electricity output. One of the main reasons that this one is not 100% safe in those areas compared to, let's say, oil and gas, is just like that amount of the water that they inject is different. So they would not have that much of impact on those structures compared to oil and gas.
Okay.
Follow up on these two questions. Minnesota. How deep?
It depends. They could go through 3 to 5 kilometers. And this is what happens usually for the oil and gas companies as well. Yeah. And then for time's sake, I'm going to skip some of those things that we'll see, but I'm just very quickly going to explain some of them because we talked about like the CO2 emission. So looking at the solar comparing to the geothermal, you see like it would be 5 centimeters per hour. And I'm going to explain like what are like some of the things that are actually causing that amount of the CO2 as well. But for the environmental impact, we do not have that risk of like the water contamination or noise pollution. Looking at the landscape impact, so this is something developed by the National Renewable Lab. So looking at the tiny photo over there, you see this major energy, and compared to the other sources of the energy, which means like that even the land use compared to the other one is smaller compared to the other sources of the energy that we have. We discussed about the thermal pollution a little bit, but regarding the noise pollution, there is a chart that actually talking about what kind of noises could be happening, like the heavy machinery, well testing, discharge, mud drilling, air cleaning, and this is one of the main reasons that if we remove the abandoned oil and gas well, some of those noises also would be removed. Some of those pollution also would be removed because they're over there, they're idle, they don't use that for a couple of the years. But if they would use that and repurpose that for the oil for the geothermal energy, we see that some of those issues will not happen. Again, we discussed about the land subsidence and induced seismicity. So some of those microseismic may happen, but as I said, from the time of 1911, that the first geothermal power plant explored, up to now, there is not too many, let's say, course, like the seismic seismicity because of like geothermal power plant, and the main reason is just like that they're always under control and they need to every time they need to monitor that different phases of the project. The disturbance to the wildlife habitat and vegetation, I know that's very important for all of us. So there is not many changes, and if I go back to the next images, you will see like that geothermal plants is in harmony with the nature. It doesn't cause any kind of problems to the plant and the animals. One of the important things for any kind of energy resource is the economy, which would be the relationship that would happen between like that source of the energy, economic activity, and the people. Of course, looking at the renewable energy job, you would see that the geothermal energy in 2023, by the report of US Energy Employment, it actually produced 8,635 jobs. So it provides like the job opportunities specifically for those who are still working for the oil and gas company. They can apply the same skills to the geothermal energy as well. What I wanted to discuss very briefly is this is the geothermal sites in the United States. Looking at these maps, you see that there are some discoveries. And I know that we're going to discuss this talk with the North region area. I just did my own research and I saw that this is the potential of each state: Minnesota, North Dakota, South Dakota, Iowa, Nebraska, Kansas, and Missouri. And this is the most pessimistic scenario. It's not the most optimistic. So as you see that those dark blue are like the lowest, and those light blue are just the highest. But the thing is that, again, I'm not considering any EGS or anything or enhanced geothermal system. This is just like considering that we're still going to use the conventional. And looking at the system that we see in Minnesota, we can use the EGS for the Northeast. North Dakota, of course, we can do the co-production with the oil and gas. South Dakota, Madison limestone is very potential for developing. Iowa has the limited direct use, but still they can geothermal system. Nebraska, Denver Basin offers good potential. Kansas has the Houghton gas field, which could be also used for the geothermal. Missouri has a limited conventional, but the EGS, as you see, will be potentially the deeper formation. And why I'm saying that, this is the map produced by the Department of Energy. This is the active project that you see in the United States. By 2040, this is what they are hoping to get. And as we see, by 2050, they believe that every part of the United States needs to get the geothermal electricity. Again, that was like a conventional one that we discussed. If any of like changes in those three components that I mentioned, we're gonna work with the EGS system because we try to improve. So it's just like enhanced geothermal system. When we do not have enough temperature, we're gonna put like those fluid carriers that actually can carry the heat. When we do not have that much temperature, we can cut the temperature inside of here. When we do not have enough the fluid, we can use those abundant, let's say, produce water from the conventional sources and repurpose that for producing the geothermal electricity. So we call that as a geothermal. As you see that the conventional is just about 40 gigawatt, and they hope that the next generation is will be about 5,500. So I'm not going to keep this kind of thing exactly. But come back. Because I know that this is something that we may want to ask for. So in 2016, actually, a specification for applying the United Nations framework classified resource for geothermal energy were developed between the UNC and the IG, International Geothermal Association. So they actually recognize the fact that how it could be helpful for the economy. And then looking at the potential that we have, geothermal energy is available in all 50 states. Okay? Yet account for only 0.4% of the electricity generation. This geological survey estimates 9,057 megawatt electricity potential from identified systems and 13,000 megawatt from undiscovered sources. And you can imagine how much big it is. So one of the issues that we have now It's just a policy. We have two issues, federal shortcoming and a state problem. Federal shortcoming, permitting process for geothermal project of federal lands can take up to 7 years, compared to 1 to 2 years for oil and gas. Which is not fair, right? So, yes. And there is also like a complex environmental and historical preservation review. When it comes to oil and gas, people are very confident. It's okay, nothing gonna happen. When it comes to geothermal energy, they're not that much confident. So they need to do their investigation more and more. And then there are like the research funding which is available, which I guess that compared that to the last couple of years, it was great because they provided at least some substantial amount of money for those who were working on the geothermal energy. And then again, we see that the Inflation Reduction Act provided help, but again, not that much for the geothermal compared to the other renewable energy sources. We also have some state level problems. Many states have no specific policies or incentive for geothermal energy. So when you go back to the portfolio of the energy for that state, you will see nothing. You see for the solar. For sure, you will see the information for the wind, but you see not much information for the geothermal. Many states renewable portfolio standard or PRS space to adequately include or incentivize the geothermal energy. And there's so many things for that, because for the production, amount of the production of the electricity that they are getting out of those wells, they could incentivize that. For the job that they're getting over, for the equipment that they're using. Although they incentivize all of those things for the oil and gas companies, they wouldn't do that for the geothermal. And again, lack of the detailed state level geothermal resource plan. When you go to each of, like, let's say, geological survey or the energy, energy department of the state, you see that there's around the states, right? Have you ever seen like what is the map of the geothermal look like in your area? Probably not, right? So this is another problem. Many of those states are still working on the researchers and the students are trying to develop the project. We do not have that much information about it. So the lack of the information is one of the problems that we have, because people, when they look at like the new source of the energy, they feel like not confident, they don't want to listen, they have some concerns, and they're not that many and actually answer the question. These are some of the questions that you may ask from your senator representative, and I guess that from the meetings that you have, the lobby meeting that you have with the senator, these are the things that I constantly push to ask from them. We support the legislation to streamline the permitting process for geothermal project on federal, because that reduces it from 7 years to match the 1 to 2 year time. These are the things that we may ask, because 1 to 2 years may improve everything. How do you plan to address the funding disparity between the geothermal research and other renewable energy sources in the state? What steps do you take to ensure the geothermal energy is adequately represented in the state and federal renewable energy incentives and standards? How can we collaborate to launch a national geothermal education camp and workforce development program to addressing the industrial skills shortage? Would you support the increased funding for comprehensive geothermal resource mapping across the 15 states? How do you propose the incentive, the repurposing of abandoned oil and gas wells for the geothermal energy production? What is your stance on providing incentives or grant specifically for geothermal energy projects? How can we improve the coordination between the federal agency, like the Department of Energy, of the land management, USGS, to accelerate geothermal development on public land? Would you support the creation of the program to encourage the entrepreneurship, technological advancement in the field of geothermal energy? So how that improved for the solar energy over the last decade, right? How would you support the integration of the geothermal into the urban planning and building codes to promote the district heating system? Which, for example, for North Dakota would be very helpful, because we wouldn't run out of the electricity energy during those harsh winter, right? And source the heat pumps in the new development. So these are some of the questions that you may ask from your senators and representatives. And being said that, I guess that there is an immense potential. Think about that 2,000 zettojoule available for extraction. This is the things that MIT said 700 megawatts is projected to be extracted in the next 50 years. Yes, sure.
Almost transmission. On par with the oil and gas.
You mean that
North,
North Dakota?
yeah.
I mean, there are some numbers available, but I cannot, probably I cannot say those numbers because it's like not my thing, not my area of expertise, and I want to say the numbers for that. But I know that the people have done research on that. So if you just Google that, I'm sure that you would find papers. People. I put like the stats for the cost over there. So I actually in this have enough time to go through that. But these are just the typical costs for the geothermal power plant. So the most of the money goes to the power plant equipment and construction, as you see. And the second one is for drilling. And this is the main reason. It's just like that. The people are just saying that if they use again the abandoned oil and gas, so that would increase. And you would see that the transmission is not that high compared to the other portion of like the cost that we have.
How about you? Make it up.
I mean, still that would be called as a geothermal resource, right? So the request and everything that I put like in the federal and state level, those issues are still happening. But even for that, you need to have like some system installed in your area.
For people making for some or heat only.
I know that they do that in Fargo. They've already done that in a couple different places because they have been some research. At least it is in the area that, but I'm sure that they are doing that in the other areas.
What is the area cost per kilowatt hour of geothermal?
To the other folks you did. I just put this one as
You had that very graphic a little while ago with, it was the color beyond the new kind of stuff. It was before you started skipping. Yeah. Yeah.
That's I was curious about, because I thought the cost that was great.
It's like the location of plants. So ideally, you could find the existing locations of power systems now and locate a geothermal system in there and plug into the existing transmission infrastructure that's already in place. A lot of coal plants in place, geological formations already. Right. And after that, dramatically reduce your costs and inputs and put them all over the map.